I am Aditya.
And I am Wearable.
And today I am excited to show you our innovation, the BlindSight. It is an accessibility device built for the visually impaired.
It is designed to help blind individuals to navigate the environment safely and independently using computer vision, object detection, and real-time feedback.
For millions of people who are blind or visually impaired, navigating through everyday tasks such as recognizing people or finding doorways can be very stressful and even unsafe a lot of times. Our solution is a wearable device that provides AI directly into their hand that sees the world for them. The BlindSight is built with a Raspberry Pi and uses a USB camera to detect objects around it using the custom-made YOLO V8 model, and it can also detect the distances of objects using our custom-made Depth ML model. So basically, it can also detect the distances of the objects and what is in front of the person, and it responds to the person using voice and also vibrations. We have also added an ultrasonic sensor for detecting distances of close-range objects and also physical buttons like this and this that increases the user accessibility of this device so that the people can just click these buttons and ask what they want and it will respond directly to them. And the best part is that it works completely offline. Now my friend will show you how it exactly works and all the features with it.
Let's see it in action. When I press this vision button here, it will tell me what's in front. Using real-time object detection, it describes the scenario to me exactly like a friend would. When I press and hold this distance button, I can speak to ask it, for example, how far is that person? And using its cameras, it can tell me its exact distance right now.
Now what you see on the screen is the backend of this project being visually displayed. So all the processes that are happening locally on our device, BlindSight, those are being visually displayed on the screen. So for example, when I ask our project that what is the distance of this particular person, it annotates the object in a blue box and also presents me with a depth map. The depth map that is generated using the on-device camera, and it provides me with the depth map and also the distance of the object that is then spoken out.
Moreover, we've also added facial recognition. So let's see if BlindSight can guess who's in front. Who's in front?
Person detected. Aryan, in the middle.
To further enhance its usability, we've also added some ultrasonic sensors which can detect objects which are not visible to the camera but are nearby. Now suppose a person wants to leave the room. Now, BlindSight will use its spatial AI to guide the person towards the exit. How do I exit?
Walk straight, avoiding tables to your left.
The BlindSight is supposed to work everywhere, whether it is indoors or outdoors, be it climbing stairs or navigating the crowd. The BlindSight is supposed to help the visually impaired in almost every situation. Now let me spread a little light on how the BlindSight exactly works. So this is a device that is based on a Raspberry Pi board, and we've also connected a webcam and an ultrasonic sensor. So basically, using the webcam, the BlindSight live streams the live footage directly to one PC that acts as a server, and the server then uses two models. The two machine learning models, that is the YOLO V8 X stands for extra large because we have also added a lot of custom models. For example, the elevator buttons, the door handles, and some other accessibility signatures that the people using our device would really appreciate. So the live footage that our model receives, it works with the YOLO V8X model and to identify what are the object that is in front of it, and also uses the ML Depth Pro model. It is a machine learning model made by Apple that allows us to identify the distance between objects just using the camera. And then there are a lot of cases where our model would not be able to see the objects clearly, so it will have a little hard time to identify what it is. So in those cases, we have added an ultrasonic sensor that uses ultrasonic sound to identify the distance, so that the user can be safe in all the scenarios and doesn't bump into things here and there. So using our both machine learning YOLO model and depth model, the output is provided back to our BlindSight device, and using speakers that are built inside the device, it speaks out the response like this so that the user can hear, and also provides vibration feedback so the user can also feel it. And there might be cases where the user would also be kind of hearing impaired. So in those cases, the user can also plug in wired headphones or even wireless headphones to hear the output better. So this is how exactly our BlindSight works.
Now let me also show you some examples from the real world.
3-person detected. Aryan to your left. Prajesh in middle. Avi to your right. Beware. Car moving left. 1.18 meters away. Beware. Stairs, 4 people ahead. Person to your left. Cell phone. Wheels. Cut. Stationary, 3.38 meters ahead, many bus to your left, many bus to your right. Text detected. Innovation hub, walk straight, avoiding tables to your left. Elevator, 7th floor, down selected.